Okay, so one pretty interesting topic that you've just been learning about is the limit process of a derivative. And what that means is that if we say that y equals f of x, there's an instantaneous slope at any given point that's called f prime of x, and that is equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And this is because you have some new y minus the old y, and you can think of this as x2 minus x1. So it's a change in y over change in x, which is why this works for the instantaneous slope. But one thing that it's not very good at is quick arithmetic. So if I asked you to find the derivative of the function f of x equals, say, 9x to the 8th minus x to the 7th plus 4x to the 5th, that would take forever using the limit process. But due to a shortcut that I'm going to show you today called the power rule, I can figure out really quickly that this is 72x to the 7th minus 7x to the 6th plus 20x to the 4th. And the shortcut is what I'm going to be showing you today. And this is a little proof of the shortcut that I derived myself. I'm not sure if it existed before. I haven't really done any research, but this is a proof that I came up with. So there's something in math called Pascal's triangle, and what it looks like is a 1, then 1, 1, then 1, 2, 1, then 1, 3, 3, 1, 1, 4, 6, 4, 1, and so on. And the pattern that this triangle has is that any number here is the sum of the two numbers above it. So, for example, 6 is the sum of 3 and 3, or for any of these on the edge, 1 is the sum of 1 and essentially 0. And for the purposes of right now, I'm going to be calling this top row the 0th row, which will make sense in a second. This second row will be the first row. This will be the second row, third row, and fourth row. And the reason that I'm calling it that is because, as you can see, these numbers here match up with the row number that I'm saying. So you can see that the nth row then, because it would be 1 plus itself n times, so the first number would be 1, because it would be some 1 plus a 0, and then the second digit would be n. And we don't actually care about any of the other digits for the purposes of this proof. But what this essentially means is that it's kind of complicated, but it means that if I took, say, two variables, let's say x plus h, and raised it to the 0 power, the coefficient is going to be 1, and it's going to be x0, h0. So that's just going to be 1. And we know that x plus h to the 0 is just 1. And then if we took x plus h to the first, it would be 1 x to the first, h to the 0, plus 1 x to the 0, h to the first. So this far side, this x variable, will have that as the exponent, and it will slowly work over, increasing by 1 until h has that as the exponent. Which I'm not going to go through every single one of these, I'm just going to skip right to the 4th power. So I took x plus h to the 4th, that would equal 1 times x to the 4th, h to the 0, plus 4 x to the 3rd, h to the 1. So you can see x decreased by 1, h increased by 1. Then plus 6 x squared, h squared, plus 4 x to the first, h cubed, and then plus 1 x to the 0 h to the 4th. And that's a pattern that will continue on for the entirety of Pascal's triangle, which is what makes it a really interesting mathematical thing. So you can see for the nth row, if I took x plus h to the n, how the first two digits would look is 1 x to the n h to the 0 plus n x to the n minus 1 h to the first, and it would continue on with some different coefficients, but we only care about these two for now. And the thing about that is it allows us to solve a derivative for x to any power, and we don't have to be specific about it. So that allows us to come up with an overarching theorem, or that's what allows us to come up with a shortcut. So if I say that f of x equals x to the power of n for this, now if I'm trying to find the derivative, f prime of x equals the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And this is where the Pascal's triangle really helps us out, because what this simplifies to is x plus delta x raised to the n minus x to the n all over delta x. And I forgot to write in the limit for that, but just keep in mind the limit will carry over for each step, obviously. And the awesome thing about this is using Pascal's triangle, we just figured out what this can be equal to. Just keep in mind, I was before doing this with x plus h. X plus delta x, this is not going to change at all. It's just I'm going to substitute in delta x for h. So hopefully that makes sense. So then that, we know, I'm just going to write it over here, will be equal to, that first one was 1 x to the n delta x to the 0. And keep in mind this is just 1. And then it's going to be plus nx to the n minus 1 delta x to the first, plus a whole bunch of other terms, which won't matter, as I'll show in a second, minus x to the n all over delta x. And I forgot to write in the limit again, but keep in mind the limit carries over. And this is obviously still a problem since we have a delta x in the denominator and the limit is delta x approaches 0, but that will cancel out pretty soon. So 1x to the n delta x to the 0, delta x to the 0, anything raised to the power of 0 is just 1. So we can just erase that. So we have 1x to the n, and over on this far end, we have minus x to the n. So we can cross both of those out. So we have the limit as delta x approaches 0 of n x to the n minus 1 delta x to the first plus a whole bunch of other terms all over delta x. And the really important thing to understand here is, as I showed before, each term as we go along in Pascal's triangle to figure out what the next term is going to be, this x exponent is going to decrease by 1, and this delta x exponent is going to increase by 1. So I don't know the coefficient of this next number, like what would go instead of n or instead of 1 right there. It's a really complicated number and I didn't really feel like solving it out. But the really important thing to understand is that the power of delta x is going to be squared. And that's really going to be important in a second here. So we can cancel that stuff out. And obviously there's going to be a delta x in every single term along the way, because the only term that there weren't any delta x's was canceled out here. So with that canceled out, we got the 0 out of the denominator, which is nice. So we have the limit of delta x approaches 0, nx to the n minus 1, plus a whole bunch of other terms. And the really important thing is, since this next term had delta x squared, and the next term had delta x cubed, and the next one delta x to the fourth, all the way until delta x to the n, when you just divide it by a singular delta x, every single one of these terms for the rest of the sequence is still going to have a delta x in it. So when we apply this limit of delta x equals 0, every single one of those is going to get zeroed out, except for this, because there aren't any delta x's after that cancellation. So that's really awesome, because what that means is that for f of x equals x to the n, the derivative equals nx to the n minus 1. So an example of this, just let me erase this real quick. So it's a really powerful theorem, and it helps make finding any derivative go way faster. So an example is, if I had f of x equals x to the 7th, in this circumstance, n would equal 7 because the exponent is 7. So we know that f prime of x equals nx to the n minus 1. So that equals 7x to the 7 minus 1, which equals 7x to the 6th. And so instead of having to take that x plus delta x to the 7th and factor it all out, which would take way too long, you can do this really, really quickly and find the derivative. And the reason why is using that Pascal's triangle and applying the limit process, and that gives us the derivative of x to the n is nx to the n minus 1. So that's kind of my explanation for why it works. If you guys have any other questions with some equation in Calc 1, just let me know. I'm going to try to be making videos like this every week or every other week. So if you have any questions that you want me to explain in this kind of format, just let me know and I'll try to make a video pretty soon.